Hello everyone, Jack here. Today we're going to make a quick tutorial on how to make your own custom ZPUino soft processor. We're going to add a couple UARTs to the design, then we're going to synthesize it, and then we'll load some custom sketch code to it. So let's get started. The first thing you need to do is there should be a link on how to download the ZPUino HDL source code. You'll need to do that, unzip it to a directory of your choice, and then go into it, enter the Papilio directory, and then depending on what hardware you have, we have a Papilio 1 500K for this demo. Go into the corresponding directory, open up the Xilinx application, should open up, and at this point you could either start working from here or you could make a copy of your project. And we're going to go ahead and make a copy. We'll call it multiple UARTs. We want to keep copy sources into the new directory and open the copy project. Okay, now we need to open up the top level file. Let's make this smaller while we work on here. And so we're going to be adding two UARTs to this design. This design, the basic Papilio or ZPUino design comes with one UART connected to Wishbone slot 1. So it already has a UART, and that's the UART that is connected to the USB virtual serial port. We're going to add two more serial ports, and what we're going to do is connect them to physical pins on the Papilio, and we will jump the two pins on the Papilio, transmit a character out one into the other one, and then pass it through the USB UART, and that will show that our two instantiated UARTs are working correctly. So let's go to, in order to add this UART, we need to bring up the reference page. So go to papilio.cc, go to reference, find the ZPUino section, and click on UART. And this shows an example of how to add instantiation code. So there's three sections that we need to follow. The first section is to add signals. So there is a convenient search tag set up. So we'll search for signal, and this is where we need to add our custom code. So since we're going to add two, we need to do it twice, and these signal names need to be unique. So we're going to do UART3. Actually, to make it less confusing, let's do UART1, and this is my UART1, and then UART2, which is my UART2. Okay. The next section we need to add is to the Wishbone section. So we'll search for Wishbone, and that takes us to where the first empty Wishbone slots are. So we're going to add our UARTs to Wishbone slot 8 and Wishbone slot 9. So we need to remove the empty device from both of the slots. We'll start with 8. We'll remove the empty device. We'll add our UART device, and we're going to call it UART1 for the first one. We need to make sure, since we're connecting to Wishbone slot, that all of these say 8. Since we're connecting to Wishbone slot 8, all of these need to say 8. Our example that we copied does say that. So let's update our signals here to match what we set up earlier. So now for our second UART, which is on slot 9, we need to replace the empty one, and we're calling it UART2, but we need to change these to be slot 9. And we also need to change these to match what we did, which that should match what we did earlier. Let's just double check. Yeah, we did UART1 and UART2. UART1 and UART2. Okay, so the third and final section is the PPS section, and this is peripheral pin select. This is what allows us to move our UART pins. So these pins here, these external pins, it allows us to move them to any physical pin on the Papilio board that we want. So let's start with our first UART. And I'm just copying in the code that I copied. So let's start with the TX pin, and let's change this so that it is UART1. Let's change this one so that it is UART1. And we see for the outgoing, the transmitting pins, the last IO that PPS slot that was used was 5. So our code example shows 6, which will work for us. So let's go ahead and do that. And then for the incoming RX pins, we see that 0 is the last one that was used. So let's go ahead and keep it like that. Alright, so now for the second UART that we're adding, we need to, it's already got the correct signal names. However, we need to use the next available PPS location for both input and output. Okay, so that's all we should. Actually, there's one thing that I think we missed. Let's go back to our wishbone area. Oh no, actually it looks right. So last time I forgot to update these labels cannot be the same. So we have updated them correctly. So we have everything we need. We should be able to synthesize now. All you do is you select the top level and you double click on generate programming file. Let's give it a second and make sure there's no errors. Okay, if it gets this far, then it looks like we're good. So I'm going to go ahead. This takes a while. I'm going to pause it and we'll be back shortly. Okay, we're back and it looks like we successfully made the bit file. So let's go ahead and load that bit file. Oh, we created a new directory, multiple UARTs. So let's load that bit file to the Papilio board. We need to write it permanently. All ZPUino bit streams need to go to SPI flash. Okay, looks like it went without any problems. And here's an example sketch I already have up and ready. The other thing is the Papilio board right now, it has a jumper between pin 0 and pin 1 on the Papilio. So let's just go through each section of this sketch. So and this sketch should also be available to download with this video. So first thing we need to do is and actually let's backtrack a little bit. If you want to see example, go back to the UART section, and there is example. If you click on the ZPUino technical reference guide, you'll see that there is a section for the UART that gives you examples of how to do software or the sketch. So the first thing you need to do is so this is based off of that. And the first thing we need to do is we need to instantiate a new hardware serial object, and we are passing what wishbone slot it's going to connect to. So we're calling my serial 1 is connected to wishbone slot 8. My serial 2 is connected to wishbone slot 9. And in setup, the next thing we need to do is we need to set up the PPS pins. And once again, you can go to reference, and there is a section on how to do this, how to set up PPS pins, and this code is pulled directly from that section. So if you go to the top, there's a reference PPS section. So the first thing we need to do is connect the transmit pin of myserial 1 to pin 0 of the Papilio. First we set the pin mode of 0 because we want pin 0. We set it to an output, and then we call pin mode PPS. Once again, we're dealing with pin 0. We turn it on, and here,
Avast virus database has been updated.
Here we are setting pin 0. We're connecting it to PPS 6. If we go back and we look at our HDL, we should see that we put the transmit pin of UART1 to PPS 6. So that corresponds, and that makes the mapping between PPS 6 to physical pin 0. Okay, for the input for RX of my serial 2, so the second serial port, we're connecting it to physical pin 1 of the Papilio. So we need to put pin mode 1, set it as input, and then we call input pin for function. We're telling it connect physical pin 1 to PPS slot 2. If we go back to our HDL, we see that for the second UART, we added the RX pin to PPS 2. Alright, and then this part we're just starting initializing the serial ports. And in our loop, we're going to write binary number 1. We're going to send it out on my serial 1. We're going to watch on my serial 2. And when there's data available on my serial 2, we will read it. And then we're going to send it out on the USB serial port so that we can actually verify that the transmit and then the read happened. So let's go ahead and write the sketch. And let's see what happens. Okay, so it's working as expected. Now I'm going to disconnect the jumper, and we see that it stops. Okay, so let's connect it back in. We'll probably get a little gibberish for a little bit, but it should stabilize at 1. Okay, so that wraps it up. I hope that gives you a better idea of how to make a custom ZPUino soft processor, how to synthesize it, and how to access the reference with examples of how you can instantiate the peripherals you're interested in. Thank you for watching.